When you have data which can be represented um, through classification and tabulation into a frequency table, graphically you can represent it using a frequency curve. So something like, if your variable is x, the x variable, you can draw the frequency curve which shows how the variable observations of the variable x are distributed along a set of values. The total frequency will be the area represented, total area under the frequency curve. Now this total area under the frequency curve can be divided into equal parts. So the values which divide this frequency curve into equal parts are called partition values. One such partition value you have already learned as a measure of central tendency, which is your median. A median is a partition value that divides your entire distribution into two equal parts. So what I call ME median, otherwise I'm calling it Q2 for the time being. This value Q2 is the value which will divide the entire observations of the x variable into two parts, right? So you have 50% of the observations falling to the left of Q2 or the median, and the another 50%, the remaining 50% of your observations fall to the right hand side. That is, the remaining 50% of the observations are greater than the median value Q2. Right? There are other important and popularly used partition values. Now these partition values are also called quantiles, Quantiles. Okay. The important quantiles, terms that you will come across are quartiles. Now quartiles divide the entire distribution into 4 equal parts. Okay. So you're talking about 3 values, Q1, Q2, Q3. General notation by convention, Q1, Q2, Q3. These 3 values will divide the entire frequency distribution into 4 equal parts. So if you have something like Q1 over here, Q2, and this is probably your Q3. So let me remove this. Okay. So your first quartile, Q1 is called your first quartile. The first quartile is the value such that less than this value contains 25% or 1/4 of your total frequency. Okay. Your second quartile, which is between Q1 and Q2, contains another 25% of the total frequency or the total number of observations of variable x. The third quartile, or the area between Q2 and Q3, will contain another 25% of the total observations of variable x. And finally, the last 25% of the observations will lie to the right of, or will be values greater than your Q3 value. Q1 is called the first quartile. Q2 is called the second quartile. And Q3 is called your third quartile. So quartiles are partition values that will divide the total frequency or the total number of observations into 4 equal parts. Okay. Now the second quartile is same as the median, because look to the left of Q2. 25 plus 25, that is 50% of the data will lie to the left of Q2, and 50%, that is 25% plus this remaining 25%, 50% of the data will lie to the right or be greater than Q2. So the second quartile is the same as the median that we calculated. So the quartiles are partition values because they will tell you the values at which the population or the total number of observations can be divided into 4 equal parts. Okay. I can say that the definition of quartiles can be: they are partition values which divide the distribution or the area under the frequency curve into 4 equal parts. So they are basically 3 in number: Q1, Q2 and Q3. Q1 is called the first quartile, and it is defined as the value of the variable such that 1/4 of the total observations lie below it and 3/4 of the total observations lie above this Q1, right? Q1. The second quartile or Q2 is that value of the variable such that half of the total observations lie below Q2 and the half of the observations lie above the second quartile or that value. Similarly, Q3 or the third quartile is the value below which 3/4 of the observations lie, and 1/4 of the total observations lie above this value. If you remember the formula of the median, the formula of the quartiles, the first, second and third quartiles are very related and similar to the formula of the median. When you have a frequency class distribution, your formula will be such: your Q1 value will be L, which is the lower limit of the first quartile class. Okay, I'm calling it L1 plus n by 4, since 1/4 of the total observations lie below the first quartile, minus m divided by f, which is the frequency of the first quartile class or the Q1 class, into C, where C is the size of the class interval. Similarly, the third quartile would be, I'm calling it L3, that is the lower limit of the Q3 class, plus okay, one second. Here the line should be in this way: L1 plus the fraction. Okay, so for Q3 the formula will be L3, which is the lower limit of the Q3 class, plus 3n by 4 minus m divided by frequency of the Q3 class into C, which is the size of the class interval. The value of Q2, like I said, is the same as median. If you remember the median, we had learned the formula as L, where L is the lower limit of the median class, plus, since the median or Q2 has half of the observations below it, so we do n by 2 minus m divided by f, which is the frequency of this median class, into C, where C again is the size of the class interval. Right? So the value of Q2 and median will always be the same because they mean one and the same thing. Okay, we can understand these formulas better when we solve an example. Similar to quartiles, now quartiles divide your frequency distribution or the area under the frequency curve into 4 equal parts in terms of area. Similar to these quartiles, we also have another partition value. They are known as deciles. Now deciles divide the entire area under the frequency curve into 10 equal parts. So there will be 9 values, D2, D3 and so on till the 9th decile. These 9 values will divide the entire area under the frequency curve into 10 equal parts. So there will be 1/10 of the total observations below D1, and between D1 and D2 you will have another 1/10 of the total observation. So below D2 there will be 2 by 10 of the total number of observations, while the remaining 8 by 10 observations of the total observations will be lying above the value D2, the second decile. Similarly, you will have the 3rd, 4th, 5th going on till the 9th decile. Okay. Finally, we also have partition values which are called percentiles. So percentiles are values, partition values, which divide the distribution or the area under the frequency curve into 100 equal parts. So percentiles will be P1, P2 and so on. There will be 99 such values, and between each consecutive percentile there will be 1 by 100th of the total observation. So P1 is the value such that 1 by 100th of the total observations lie to the left of or lie below the value P1. And P99 or the 99th percentile is such that 1 by 100th of the total number of observations lie above or are greater than the 99th percentile value. For the quartiles, if I write the formula in general terms, Qi, where I can take the values. Remember, when your quartiles divide your distribution into 4 equal parts, so you will have 3 values. So there are Q1, Q2, Q3. There are 3 quartiles possible. So Qi, where I can have the value 1, 2 or 3. The general term will be, general formula will be Li, which is the lower limit of the corresponding quartile class, plus in brackets I can write I by 4 times n. Remember, your capital N is your total number of observations or total frequency summation f, into C, which is the width of the class interval, divided by the frequency in the corresponding quartile class. So here I have used the subscript I so that this one formula can be used for Q1, Q2 as well as Q3, right? So in similar notation, I can write the formula for each decile. So the decile, since there are 9 values, your I can go from 1, 2 and so on till 9. 9 values are required to partition the entire area under the distribution curve into 10 equal parts. So di can be written as Li plus I by 10 times n minus m divided by frequency f into c. Remember here m is the cumulative frequency till before the decile class that we are concerned with. F is the frequency of the decile class that we are trying to calculate. Li or L is the lower limit of the decile class that we are trying to estimate, and C is the class width or the size of the class interval. Now similar to this formula, we can also write a formula for percentile. Percentile, the values of I will go from 1, 2 and so on till 99. Right, there are 99 percentile values that you can calculate. Formula is similar. Li is the lower limit of the percentile class that we are concerned with. I by 100, since percentiles divide the distribution into 100 equal parts, times n, which is my total frequency, minus m. M is the cumulative frequency up till the percentile class that I am concerned about. F is the frequency corresponding to the percentile class. C is the width of the class interval. Right? So just remember the formulas in these general form. Then you can just change the value of I and calculate any partition value that is required. If you observe, all these formulas are very similar to the formula of calculating the median. So if you can learn one of those, you just have to make small adjustments to arrive at a formula for a decile or a formula for a percentile. We can have a look at how to calculate these partition values using some of the sums given in the book.